Hello AP Stats students, Mr. Hazelhorst here with your Chapter 8, Section 1A video. Just a couple reminders before we get started here. I want to remind you of some things that it takes to make the most use of these videos. So I want to encourage you to pause the video as you need to. If you need to write something down, feel free to rewind and rewatch something that maybe you didn't pick up on the first time through, and take notes. All right, that's probably the most important thing. And then last but not least, remember to complete that Google form below. Leave me any notes or thoughts from what you saw in the video today and anything that you want to see me cover in more detail as we get back to class together. All right, so today we're going to talk about the binomial distribution. We're just going to jump right into it. Today is going to be more introductory. So I first want to talk about the characteristics of a binomial distribution. We'll wait until the announcement is done.
Please call 4614.
All right, so characteristics of a binomial distribution. Three things that we need to look for. Number one is that there are only two outcomes, and this should make sense just based on the prefix of what we're talking about here, a binomial distribution, right? We know that bi means two. All right, so only two outcomes. We want a fixed number of trials, and we want events to be independent. All right, if we have those three things in place, then we could classify something as following a binomial distribution, and then use that to find probabilities and study an event in more detail. Okay. Now, a little notation to be aware of, similar to what we've seen with the normal distribution before. If we see a capital B followed by a set of parentheses, and we'll see two numbers inside that set of parentheses. The first value will represent n, which you can see we listed up above as a fixed number of trials. And the second number will be p, which will be our probability of success. Now, when we say the word success, I kind of need to clarify something right from the beginning. We're not talking about something that's necessarily good or beneficial. That's kind of how we typically use that word. Hey, a success, great, good things happen, right? But when we talk about a success in a probability setting, it's an outcome that we're studying, okay? So that might be something we view as good or bad. We're not talking about that setting. We're considering a success, again, whatever we're studying. So the probability that our event that we're studying happens, the probability of success, all right? So those two values combined make up part of the notation that we'll see with the binomial distribution, okay? So what I'm going to do next here is I want to give you some different situations, and I want you to think about if these situations hold true for all three of our characteristics. Do we see only two outcomes? Do we see a fixed number of trials? And do we see events that are independent? All right, so let's start out with our first trial. The number correct on a 10-question true-false quiz, okay? So if we think about that setting, are there only two outcomes in this setting? And most of us would probably say yes. You either answer true or you answer false. Okay? Now, we really don't care about the true or false part. Let's go back to what it said before. It says the number correct. Okay? Now, true might be correct, false might be correct, but what makes this binomial is the fact that we only have two outcomes, correct and incorrect. All right? So yes, we have only two outcomes. We have 10 questions, so we have a fixed number of trials. And if we think about a true-false quiz, all of those questions have the same probability if you just flat out guess, right? Since it's true-false, it'd be 50% for every question would be our correct, okay? So if we look at setting number one, we would say yes, this is binomial, all right, meeting all three characteristics that we want to see, okay? Second example. All right, how about the number of red cards when 7 cards are dealt? So do we have two outcomes here? Well, I think we'd all agree, yes, we do. They're either red or they're black. Do we have a fixed number of trials? Again, we would say yes. We have 7 cards that are being dealt. The last question that we need to answer is, do we have independent events? Well, what do we know about dealing decks from a deck of cards? Well, hopefully you remember the probability is going to change. So this one would not be binomial. Right? And the reason being, we do not have independent events. Okay? Again, that probability is going to change from one trial to the next. All right? So how about another one here? All right, how about the number correct on a 10-question multiple choice test? If there's 4 choices per question. So do we have only 2 outcomes? Now, some people might think, oh, no, we don't. We have 4 outcomes. Right? We have 4 possible outcomes. Well, again, remember when we're talking about a test, we don't care about did you answer A, B, C, or D. We care about did you answer correct or incorrect. So we still have only 2 outcomes. We have a fixed number of trials, and we have independent events. So yes, this would be binomial. All right? And then the last one, how about the number of heads when flipping a coin? Well, we have only two outcomes, right? Either get a heads or tails. And we have independent events. We know the flip of the coin stays consistent throughout. But this one's not binomial. And the reason being, we haven't specified how many times we're going to flip that coin. All right? So those are the things that we want to think about as we look at a setting to consider is it binomial. All right? So hopefully that helps you in that context. So if something is binomial, well, then we can apply what we know as the binomial probability formula. And you can see this formula in your gold packet. All right? So it's really a pretty simple formula. Okay? And to kind of illustrate how this works, let's think about if I were to roll a die and ask, right, how many sixes do you roll in rolling a die, let's say 3 times? Okay? Well, we know that there are only two outcomes in that setting, right? You either roll a 6 or you don't. So if I tree diagram this out, all right? So let's say we got a 6, not a 6, all right? 6, not a 6. 6, not a 6. And 6, and not. All right, so if I roll a die 3 times, I know that it's possible that I obtain no 6s, right? That's what we see on this outside branch, right? Over here, we have 3 rolls, not a 6, okay? It's also possible I get 1 6. Now, this is where the formula starts to kick in, right? If I take a look at the formula, right, it's taking p raised to a certain power, right? How many times do I want that success to occur? So let's say I'm interested in rolling 2 6s, right? Well, it'd be 1 6 to the second power. Right? And then we also want the third roll to not be a 6. So that's where this 1 minus p kicks in. Okay? But this is the part that we need to make sure that we understand when it comes to binomial. Right? This is what we refer to in mathematics as a combination. And you might remember this from pre-calculus or algebra 2. Right? We talk about permutations and combinations. This is a combination. Because when I look at this setting, right, rolling 6s when I roll a die 3 times, right? Well, if I'm interested in 2 6s, this can happen different ways, right? This would give me 2 6s. This branch would give me 2 6s, and this branch would give me 2 6s. So there's multiple ways for that to happen, all right? And that's where our combination kicks in. All right, so let me clear some things up here. So when we talk a combination, just a reminder about that from your Algebra 2 or pre-calculus days, right? So this is our formula for a combination. Now, we're not going to concern ourselves too much with the formula because I want to show you this is built into your calculator. So if we pull up your graphing calculator, we go into our math menu. We scroll over to probability. Oops, a little too far there. You can see the third item in the list here is a combination. Okay? So that's what we're talking about here is this idea of a combination. So that's a part of the formula. It's talking about how many ways can this happen. And then we multiply through those probabilities, and that's part of the binomial probability formula. Now, this isn't a formula you need to worry about memorizing. Again, it's in your gold packet, and it's also built into your graphing calculator, and that's what I want to show you how to deal with today. All right, so this slide, you can see there's some steps on your calculator, and we need to talk about the difference between a PDF or a CDF. So the first thing that I want you to do here is pause the video and take a moment to write down this information. All right, if you printed out the slides, you can just keep watching. But if you're taking notes on your own, I'd encourage you to have these in your notes. So go ahead and pause the video real quick. All right, so let's talk about a PDF or a CDF. So in a PDF, all right, PDF stands for probability distribution function, okay? And it's used to find the probability of a single event. So let's say I wanted to find the probability that if I have a family of 3 kids that that family has 1 boy. All right, or let's change it to 2 boys. That family has 2 boys. Okay, that's a specific setting, probability distribution function. All right, CDF is a cumulative distribution function, and it's used to find the probability of at most situations. All right, now let's talk about this phrase at most for a moment. Okay, if I say, let's say I'm going to flip a coin 10 times, and I wanted to find the probability that I have at most 5 heads, okay? If I say at most 5, what are all the settings that satisfy at most 5, right? Well, if we stop and think about it, that's the number 5, or 4, or 3, or 2, or 1, or 0, right? It's 5 and below. That's where that at most setting kicks in. And that's what we want to keep in mind is we think about, should I use a PDF or a CDF here, okay? And the reason why that's important for us to decide, if you look at the steps on your calculator, right, over here, in our distribution menu, we have a binomial PDF and a binomial CDF, okay? This fits in line. We always chose the normal CDF, right? Because it could set up this interval, okay? A little bit different here, but the same idea, all right? So notice the input values that we need to give. We need to give our number of trials, our probability of success, and how many successes we're looking at in this case. So let's take a look at some example problems, and if you have your graphing calculator, pull that out so you can kind of follow along with us here. All right, so let's jump right into it. So let's say among high school seniors, 25% have never had a job. And we want to select 10 high school seniors at random. So the first question we have to ask is, does this situation follow a binomial distribution? Right? And if so, what are N and P? Okay? So again, think of our 3 characteristics. Well, if we look here, we have 2 outcomes, right? They've either had a job or they haven't. Okay? So yes, we can say, okay, 2 outcomes, check. All right, do we have a fixed number of trials? Well, yes, we do. All right, we're selecting 10 of them. Okay? So, yeah, we can check that one off as well. All right, third outcome, are they independent? Well, this might be one where you're not quite sure of, but let me talk about a very important phrase that we're going to deal with quite a bit moving forward in this class, and that's the phrase at random. All right, if things are selected at random, that allows us to assume independence. Okay, so yeah, we're going to say these are independent events, again, because they selected them at random. Right? They didn't select them with bias or through a convenience sample, but we can assume that everybody is separate from each other. Therefore, nobody's going to have an impact on the other outcomes. All right? So, again, we've got everything that we need here. So, N in this problem, again, fixed number of trials would be 10, and our probability of success, and we're considering the fact that they've never had a job a success. Now, some of you might consider that success as well, but I'm here to tell you, you better have a job. That's a lot more successful. But that's another conversation for another day. All right, so let's jump into our actual example problems. So first off, this says, what is the probability that exactly 2 of the 10 seniors in your sample have never had a job? Okay, so the first decision we have to make, is this going to be a PDF or a CDF? And again, remember, PDF is used to find the probability of a single event. That's what I have here, right? We want exactly 2. That's it. Nothing above that, nothing below that, 2 and 2 only. All right, so this is going to be an example of a binomial PDF. So if I set up that word, all right, if I just write out what's going to go into my calculator, right, I'm going to do a binomial PDF. We'll pull up our calculator here in a moment. And my sample size is 10. My probability of success is 0.25. And K in this problem would be 2. So that would be the input that I'll put into my graphing calculator. So let me pull mine up here real quick. Oops. I'm going to switch sides here so we can still see the question. So if we go ahead and input this into our calculator, all right, I'm going to go into my distribution menu, and I've got to scroll down a little ways here. I think it's letter A. I don't remember exactly, though. Yep, letter A, binomial PDF. My number of trials is 10. My probability of success, 0.25. And my number of successes I want in this problem is 2. So if you have the newer type of calculator, this is the display that pops up. Those of you with the older model, this is what your input will look like. We go ahead and press enter, and there's our probability. So we have about, we'll say 28% chance that if we select 10 students from this population, that exactly 2 of them will have never had a job before. All right? So for them, I feel bad for them. No experience. All right, so let's move on to our part B, or excuse me, part C. So this one says, what is the probability that 2 or fewer have never had a job? Okay. Now think about that phrasing there. When we use that phrase 2 or fewer, what are all the settings that could satisfy this situation? Right? So 2 or fewer, well, it could be 2, or it could be anything less than that, 2, 1, or 0. Now, if we think about that, this matches what we said about a CDF, right? This is that at most setting, right? Another way we can phrase this is what's the probability that at most 2 have never had a job? Well, okay, we know what to do in this problem then. I need to apply a CDF, okay? So the only thing that's different about this problem is my choice to use the CDF. The input remains the same. So I'm still going to have 10, 0.25, and 2. Okay? So all those things still apply. All right. So again, we input this into our graphing calculator. Again, I'm going to choose my distribution menu. I'm going to scroll down again. So the one I want this time is B. So I'm going to choose my CDF. My number of trials is 10. My probability of success, again, is 0.25. My K value is still the same. It's 2. I'm going to hit paste. And my probability here. Now, notice that this probability is higher than the previous problem, which if we think about it, should make sense. If it's a CDF, it's calculated the probability of not only 2, but also 1 and 0, and it's added all those together. So our probability this time comes out to be about 53%. Okay, and that's that at most, that CDF setting. Okay. Now, one more type of problem we want to be aware of as we deal with this binomial setting is this last type. So this says, what is the probability that at least 4 have never had a job? Okay. Now, again, look at the wording that we have available to us here. It says at least 4. Okay. So let's again think about, okay, what are all the numbers that would satisfy this statement? Right? So at least 4. It could be 4, 5, 6, right? All the way up to 10. Now, does this fit our at most setting? Well, it doesn't, does it? Right? We can't say at most 4. I can't even say at most 10, right? Because even if I said at most 10, well, that only works down till 4, and then once I get to 4, I don't take anything else. So we need to think about, okay, how can we take what we do know, what we do have available to us, either a PDF or a CDF, and we can make it fit to the setting. Right? Well, it's kind of like the at least problems that we did in our probability chapter. Right? What we're going to apply is a complement. Okay? So I recognize, okay, I need 4 and above. Right? Well, which numbers are not included here? Well, what we don't want included is I don't want 0, 1, 2, or 3. Well, these numbers meet that idea of a CDF. So what I can do here is I can apply the complement of a CDF. So I'm going to go 1 minus the binomial CDF of 10.25, and I'm going to go to 3, right? Because what my binomial CDF is going to find is the probability of 3, 2, 1, and 0. It's going to add those all up. And then if I subtract that from 1, that gives me the other probability. Right? So our binomial CDF, while it's designed to work with at most settings, we can apply the complement in an at least setting. And that's what we see here. So let's do this problem on our calculator real quick. Right? So again, 1 minus the binomial CDF. So I'm going to go to my distribution menu. And we'll scroll down. Wait for my slow calculator to catch up. There's our CDF. You guys are not dismissed yet, so ignore that bell. All right, 10.25, those values copy over. Now I want to change the 2 to a 3. I hit paste. I can hit enter. All right, and there's our probability. This is our probability that at least 4 have never held a job. So we're right at about 22%. And that's a whole heck of a lot faster than finding the probability of 4, and then 5, and then 6, and then 7, and 8, and 9, and 10, and adding all those together. Again, we can apply the complement and the CDF to help us in those at least settings. Okay? So that's your introduction to the binomial distribution. As always, I want to encourage you to complete the form below the video. Today we really just focused on what is the binomial distribution and how do we use the formula, but those are going to be extremely important skills. So if you have questions on any of that, as always, please ask. And I hope that you guys have a great day, and we'll see you.